and welcome to this video on Fundamental Big Data Concepts, a Beginner's Guide. In today's data-driven world, the term big data has become universal, yet its true meaning and potential are often misunderstood. This video aims to demystify the foundational concepts of big data, providing you with a clear understanding of what big data is, its key characteristics, and the technologies that empower its management and analysis. Whether you are an aspiring data analyst, a business professional, or simply curious about the impact of big data on various industries, this guide will equip you with the essential knowledge to navigate this vast field. Join us as we embark on this enlightening journey into the world of big data and discover how it shapes our lives and drives innovation across sectors and verticals. Let's get started. Big data refers to exceptionally large and complex data sets that are generated and collected from various sources, including social media, sensors, transaction logs, and much more. It encompasses a combination of structured, semi-structured, and unstructured data, which traditional data processing systems often struggle to handle effectively. Big data is characterized by three primary aspects: volume, indicating the vast amounts of data being produced; velocity, the rapid speed at which the data is generated and needs to be processed; and variety, highlighting the diversity of the data that must be managed. So we'll talk about all of these aspects a little bit in detail as we move ahead. Over the recent years, additional characteristics such as veracity, again we'll be talking about it in detail. Veracity addresses the quality and reliability of the data, and value, which emphasizes the importance of extracting the meaningful insights from that data, which is how much valuable that data is. These have also emerged as essential components of big data. The rich landscape of data can offer organizations significant advantages, enabling advanced analytics, informed decision making, and innovative business strategies. Now let's talk about the 5 V's of big data in a bit detail. We've just touched base upon them in the previous slide. These 5 V's, all starting with the letter V, that is why the 5 V's, are the characteristics of big data: volume, velocity, veracity, value, and variety. Volume refers to the sheer scale of data generated, which can range anywhere from terabytes to petabytes. This massive amount of data comes from diverse sources, including social media interactions, business transactions, and sensor data from IoT devices. These are just some of the examples. Many a times we have to combine data from various sources, and that leads to X times increase in the size of the data. The challenge for organizations lies in storing, managing, and processing this large volume of data or information without losing the valuable insights contained in it. Next is the velocity, or the speed at which the data is produced. Velocity also brings to light the necessity for the real-time processing of the data being generated. In industries like finance and healthcare, timely insights are critical for making quick decisions. As soon as the data is generated, it is important that it gets processed and related insights are presented to the user to make a decision. Companies or businesses have to adopt technologies and facilitate rapid acquisition and processing of data to provide actionable information almost instantaneously. Next, we have veracity. Veracity is concerned with the quality and the credibility of the data. High veracity means that the data is accurate, trustworthy, and reliable, which is essential for informed decision making. Poor quality data can lead to erroneous insights, ultimately affecting strategic choices and outcomes in organizations. Therefore, ensuring data integrity has to be very important. Processes like cleaning and validating the data before it can be used for analysis ensures that the veracity of the data is on point. Next is the value contained in the data. Value refers to the usefulness of the data in simple terms. The usefulness in generating insights that inform business strategic decisions, plans, etc. Data alone may hold limited significance. It is the insights drawn from the data analysis that create real business value. Organizations are increasingly focusing on capturing the value from big data to enhance operational efficiencies, boost their revenues, and improve customer satisfaction, thus leading to better business outcomes. Lastly, we have variety. Variety involves the different forms and formats of data. In the realm of big data, information can be structured, like the numerical data or tabular data, semi-structured like JSON files and XML files, or unstructured like emails and images. Unstructured typically means we don't have a fixed length. This diversity presents challenges in parsing and analyzing data effectively because different types and formats require different methodologies and tools for the interpretation. For example, text data requires a different set of tools and image data requires a different set of tools. So that is the variety part. This is a very important question that must be coming to your mind right now. Why do we have a special set of methods and a whole new area to deal with? After all, it's all about data. Well, the answer lies in the difference. Firstly, it's about the structure. Big data has vast data sets that include structured, semi-structured, and unstructured data, like we just discussed. However, traditional data primarily consists of structured data. There are proper schema organized in relational databases. Traditional data is maintained within a fixed schema, allowing only organized data to fit neatly into predefined fields and tables. There are predefined columns, predefined rows, everything is fixed. And therefore, it is easier to manage and analyze. However, the big data, in contrast, employs a more flexible, dynamic schema, permitting the inclusion of various data types that do not conform to traditional structure formats. Secondly, the difference is in the quantity or the size. Traditional data typically involves datasets measured in gigabytes or terabytes. They can be centrally stored and managed easily. On the other hand, big data has much larger datasets that can be measured in petabytes and zettabytes or even exabytes, right? We don't commonly hear these units. So you can imagine how huge the quantity of big data is. Therefore, it necessitates advanced storage solutions and distributed system architectures like Hadoop. Another major difference is the rate of generation. Big data is generated at an incredibly high speed, meaning that data flows in rapidly from multiple sources, frequently requiring near instantaneous processing to meet the demands. Traditional data processes, however, usually create updates periodically, leading to a less dynamic response to data changes. The ability to perform real-time analytics is a distinctive feature of big data that traditional systems generally do not accommodate. Lastly, the diversity of big data. We have been talking about this for quite some time. Big data captures a wide array of data from diverse sources. As I was talking some time ago, we have a lot of sources and we combine data from all of these sources when we sit for analysis, right? So these sources include social media, then sensors, emails, images, videos. However, traditional data predominantly comes from enterprise applications like your CRMs and ERPs. The multitude of sources for big data contributes to the richness as well as the complexity of big data, necessitating again the advanced techniques for effective management and analysis. Now let's understand the types of big data. Big data can be classified into three primary types: structured data, unstructured data, and semi-structured data. Understanding these categories is essential as each type presents unique characteristics and challenges for data storage, management, and analysis, therefore impacting the effectiveness of big data analytics in various applications. Starting with structured data, which is organized data in a highly defined format. Therefore, it is straightforward to analyze and process. Structured data typically follows a predefined schema and is stored in relational databases such as SQL. where information is grouped into rows and columns. Examples include customer information, financial transactions, inventory management data, etc. Such type of data can be easily queried and analyzed using standard data processing tools. Overall, structured data is the most accessible type of data to work with due to its arrangement and predictable format. Exactly opposite is unstructured data, which lacks a predefined structure, making it more challenging to interpret and analyze. This type of data includes various formats such as text documents, images, videos, and social media posts, which do not conform to specific schemas. Because it accounts for a significant portion of the data generated today, estimated to be more than 80%, unstructured data requires specialized tools and techniques for analysis. Analyzing unstructured data often involves transforming it into a more structured format to extract meaningful information. Lying somewhere in between of these two structures, we have semi-structured data. It kind of bridges the gap between structured and unstructured data, containing the elements of both. In semi-structured data, the information is generally organized using tags or markers that separate different data elements, but without a fixed schema. Examples of semi-structured data include XML and JSON files, which may possess structured metadata alongside unstructured content. This type of data allows for more flexibility than strictly structured data, but can still be somewhat complex to manage and analyze due to its lack of rigid structure. After that, we have two more types of big data, which have recently come up: quasi-structured data and subtypes of data. Let's see what these means. Quasi-structured data is another classification that possesses some organizational characteristics but does not fit neatly into traditional database schemas. Now let's see the sources of big data. Big data originates from a multitude of sources, which can be broadly classified into structured, semi-structured, and unstructured types. Right? As I said, the last two, quasi-structured and subtypes, have recently come up. Common sources include social media platforms, where massive volumes of user-generated content and interactions are recorded daily, and Internet of Things devices that continuously generate real-time data from various sensors and applications. Other significant sources are transactional data from e-commerce platforms, user logs from web applications, multimedia content such as images and videos uploaded on various sites, etc. This diverse range of data types and sources contributes to the complexity of managing and analyzing big data, making it formidable asset for organizations aiming to derive actionable insights and improve decision making. I hope now the picture is getting clearer. Now let's see what are the challenges. Now, despite all the advantages, all the capability, all the value contained in big data, there are challenges. And that is why there's a whole different area that you need to deal with. The major challenges include data quality issues, storage concerns, need for skilled professionals. One of the major challenges is dealing with the immense volume of data, which can overwhelm traditional storage systems and necessitate the use of advanced solutions like cloud storage and distributed databases. Additionally, the velocity at which the new data is generated requires real-time processing capabilities, which many organizations struggle to implement, right? Both in terms of resources and in terms of financial aspects. Another critical issue is ensuring data quality and accuracy, as large data sets are prone to contain duplicates and errors, leading to faulty insights. Furthermore, integrating data from diverse sources can lead to silos, reducing overall visibility and potential insights while complicating data management efforts. Lastly, we have privacy and security issues, which are large with big data. Because the vast nature of big data makes it a target for cyber threats and therefore raises the privacy issues related to sensitive information. With that, we need to talk about the future of big data. The future of big data is posed for dramatic transformation as organizations are increasingly seeking to harness the value of continuous and real-time insights from vast data sets. Advances in technologies such as artificial intelligence and machine learning are enabling more sophisticated analytics and predictive capabilities, allowing businesses to make data driven decisions faster and with greater accuracy. As cloud technologies evolve, companies will benefit from virtually limitless storage and processing power, facilitating the management of increasing data volumes without hefty investments in physical infrastructure. So, one by one, all the challenges will be overcome in the future, and this would become very, very common. The democratization of data through user friendly no code platforms will empower a broader range of stakeholders to analyze and utilize data independently, fostering a more inclusive data culture within organizations. This shift is accompanied by an emphasis on data governance and quality management, highlighted by the growing role of chief data officers to ensure that organizations leverage their data responsibly and effectively. Ultimately, the integration of generative AI and advanced analytics will redefine how businesses approach their data strategies, making actionable insights more accessible than ever before. If you're keen on learning big data technologies, we can help you get started. Enrolling in our structured course will provide you with essential knowledge and skills, enabling you to master a variety of tools like Hadoop, Spark, and NoSQL databases. These technologies are pivotal in managing and analyzing vast data sets effectively. The course will include hands on projects, allowing you to apply your newfound skills in practical scenarios. Moreover, with the growing demand for big data professionals across various industries, you will be building a strong foundation in big data and opening up a diverse career opportunities significantly enhance your professional portfolio.
Thanks for watching the video. Our knowledge partners, certification alliances, and curriculum creators are. Join our popular courses and get an immersive learning experience as we proudly serve as a global trailblazing training solutions provider. Dealing with braining a revolution in upskilling by offering comprehensive and specialized training programs. Following are our services: instructor-led virtual training, on-site training, corporate training, exclusive and individual training, self-paced training, classroom training, customized training, campus training. To know more about our courses, visit our website. Don't forget to like, share and subscribe the video.